Hey everybody, it's Danger here. So I shot this video and during editing the file was corrupted, but it was basically a video where I built this pendant you're seeing now and showed how to solder and all of the 101 basics of soldering and building a pendant. So we're gonna do it again. So here's soldering 101. So here is a demonstration of how to make a pendant. We're going to cover soldering basics, uh, keeping in mind these kind of main points. We want all of our connections to be tight. Our surface prep is very important because solder does not like to flow on dirty surfaces. Uh, Even heat and heat distribution. Um, some little subjects of that would be the distance of your flame from your pieces, the focal points of where you're actually pointing your flame, and the silver thickness of the parts that you're trying to put together. All things you need to keep in mind. Then we're going to talk about fluxing your pieces before solder, and then the solder type you're going to use for what connection you're doing, as well as like how much solder to use, and then how to control the flow of the solder. We have a decorated bezel that's stamped, so there's indentations that we need to protect from solder filling them up, or else it's just gonna be all for naught. All that stamping that you did is going to get filled in with solder if you don't protect it. You'll notice that I have my backer material is much cleaner than my bezel material, and that is by design. Uh, as I stated earlier, solder does not like to flow in dirty surfaces, and before we actually make this connection, we're going to dirty it up even more, and I'll show you what we're going to do for that. Bezel's formed up, so I'm going to give myself a mark. You can see my score mark there. We're going to cut it a little bit before that, essentially giving us a little bit of extra material. This joint needs to be tight and free of gaps, so we're going to square it up and get that gap out of there. You can do this with a file or a jewelry saw. I'm going to use this barrette file. Even if one of your sides is like nice and square and it's been square the whole time, doesn't matter. You want to take your file and touch it anyways, because you want to make for certain that that edge is going to be nice and clean and ready to accept solder. So now, as you can see, when it's pushed together, it's a nice clean connection, no gaps. Take it and do like a jump ring and kind of push one end over the other until they come together. Minor corrections to the connection. And you want these like with pressure on each other. Now this is ready to get joined together. But before you get too crazy, make sure that you're going to fit over your stone and that it's not going to effectively pry open your joint. because if that's the case, you're either going to need to plan to trim your stone down if you have the ability to do that, or make a new bezel. But in this case, we got like a perfect fit. As far as prep goes, some craftsmen may find this unnecessary, but what I like to do is take a square or a triangle file, and that joint right there on the inside, I'm gonna run one of the corners in that joint and just clean up that joint right there. And this just ensures that I can get a good flow of solder all the way through. And we're not going to do it on the front because we have a design here. We're going to want that as dirty as possible. And that leads me to my next part, is getting that design dirty so that we can solder it safely without filling our punch design. So let's get into that right now. Okay, so the things you're going to need for this step is some rouge or polishing compound. This usually comes in Dremel kits, but it's that red, really thick, waxy feeling type stuff. You need some of that. You're going to need some borax, and you're going to want it ground down fine. So make sure that you have a way you can grind this down, whether it's in a bag and you roll a rock or a rolling pin over it several times, or you can use a mortar and pestle to get it nice and finely ground. Next thing you're going to need is a container to mix these things up in, a brush to apply, and I would recommend something that has a finer tip, and finally some distilled water. Start by setting up your container and getting some rouge. There's not really a specific ratio for this. You're just going to kind of mix these parts together until they make a nice consistency paste, or whatever consistency you're looking for in your stop flow. I like to go for something that's somewhat in between a paste and like a slurry. The borax, since this is wet, like a waxy substance, the borax is meant to help it break down. So typically start with about this much, and then I'll just add enough distilled water to make it wet. Okay, there we go. Alright, so now you're just gonna mix that on up, and you may want something a little bit more firm than a brush. I just turn my brush around and use the back of it, and what that's going to do is mash up some of those chunks of rouge. And also it's going to help to finish mashing up the borax, any bigger chunks of borax that are still in there. If you don't like how much water you got in there, just dip a paper towel in there. Let it wick the water up. We don't want it too watery now, because that's going to cause it to like flow into cracks and crevices and stuff. And one of those cracks and crevices that it could potentially go into is our solder joint, and that we definitely do not want. That is better. Okay, so that is the consistency that I like to go for. All right. So while being mindful not to touch with your hands, you can get your stop flow on your brush here and start with a little, because it's easier to put it on than it is to get it off. Don't go near your seam yet. See how the consistency of this stop flow is, because you could very well go up close to the seam and it slurps it right in there. It happens. So make sure you're testing your stop flow. Okay. And then no need to leave like there's no need to leave like a little bead or a little dewdrop anywhere. You can just pull that stop flow right back away from where you touched it. It's already dirty now. And then you can just continue on. I likely will not have to add any more stop flow to my brush for the rest of this piece. Now, right here, you can see one of our designs actually goes right up to the joint. So I'm just going to touch before that. And I'm going to let that liquid just kind of permeate that way a little bit. And I'm going to leave it just like that. I'm not going to mess with it anymore. Okay, now you have your stop flow all the way around. And you may be asking yourself, well, why'd you go all the way around? You're only soldering one joint. Well, the answer is because this will save us a little bit of time later. If you don't have to pickle in between every step, like for instance, I'll solder this and I'm not going to pickle it after that. What I'm going to do is just flush up each side and get it soldered up to my back plate. And then once that's done, I probably still won't pickle it, and I'll get my jump ring soldered on. At that point, I'll pickle the whole setting. So this will save us a little bit of time getting all this stuff back out later to do what we could have done right now. So our stop flow has moisture in it. Our flux also has moisture in it. We do not want these two mixing at all. That would be bad news. You would find yourself having to stop and clean everything off and restart the process. So now we get to do the fun part and get the fire going. So just a real lazy flame. Okay. You can turn your flame down. If If you can control your heat, um, you're going to have better results. If you can control the air and the gas intake, then you're going to have better results. You can really key stuff in. Um, However, I started on a little Coleman propane torch and just held the bottle in my hand, and learned that way. So everybody starts somewhere, but I would highly recommend a torch that you can control the intake of gas and air. You can control that mixture. So all I'm doing here, just gently drying that stop flow. I'm not trying to anneal the metal. I'm not really even trying to get it hot. I just want to dry all the moisture out of that stop flow. That's it. Let's take a moment to talk about flux. There's a couple different flux types. Some flux will pickle at the same time. This is one such flux that is a self-pickling flux. And what that means is that it will keep the metal from oxidizing. A pickle removes the oxidization from silver. So when you hear that term, that's what it's referring to, is the process of removing the oxidization. Flux is the thing that allows your metal to bond together under the heat. Without the flux, your solder will not want to flow. It will just sit there. If you don't have liquid flux, can't afford it, can't source it, whatever, you can use borax and alcohol, just regular old rubbing alcohol. Some people even use borax and water. Borax is a really good flux. It is what you use to season your crucibles, to glaze them, and that prevents the silver from basically sticking to the inside of the crucible. It also helps to draw the impurities away from the silver. So borax, very good um, to have in your workshop, because if you run out of this or if you spill it like I did, I mean, this should have lasted me forever, um, because you use such a small amount on each joint. So if I ever ran out of this, I could always mix up some borax with some rubbing alcohol and make it happen. So now we're going to flux this joint. Now you see that dewdrop on there. I do not want that dewdrop on there when I touch this, because there's that stop flow on there, right? So I want the brush, I want it saturated, but I don't want it dripping wet. Something else is when you heat it up after it's been work hardened, it wants to start relaxing. So make sure you check it after you heat it up. Make sure you check it after you heat it up, because it could shift in one direction or another and create a gap. When you heat flux, it turns to like a glassy type of a substance, and it really makes your joint stick together. It's almost like sugar. Like when you heat up sugar, it gets gooey and then it gets hard. Again, with that brush saturated, but not dripping wet. I'm going to take it, try and steady my arm, and apply it from the back. This leads into our next subject of solder and solder types. These are what's known as pallions. These pallions specifically are an easy hardness or easy heat, which refers to its melting point. The material is silver, but it's an alloy of silver, which means it has something else added into it to change its melt point. And why this is important is because the silver that your piece is made out of is going to need to be a higher melt point than the solders that you're using. The metal that we're using here and the metal that I use predominantly is a 940 silver. It's a 940 argentium silver. What that means is it has germanium in it. This is germanium. It's alloyed with silver and copper to make argentium silver. It's pretty brittle and it's very bright and shiny. I'm sure I could do a whole video on argentium silver, as I am very biased because it adds extra brightness, extra tarnish resistance, it improves the durability, and it just makes for a nicer metal to work with as far as silver's concerned. You need to make sure that you don't quench argentium silver. Because of that brittleness, you could cause little fractures in your alloy. And it also allows you to fuse the silver as opposed to just having to solder it. You can literally fuse like your bezel ends together. Here you can see an artist, goes by the name of Josh L. Designs. He's fusing argentium rings together without solder. For a beginner, if you have 3 different solder joints, to keep yourself safe, you're going to want to use a hard solder, you're going to want to use a medium solder, and you're going to want to use an easy solder. One for each step, for each joint that you have. Now, if you have 4 joints and you're a beginner, there are extra easy solder, and there are some in-between stages as well. You can also make your own solder, which we won't get into in this video, but essentially the idea is you're alloying the pure silver with another metal like zinc to lower the melt point to where your solder melts before your piece does. Because I need to pick a solder for my bezel, and the only really smart choice is using a hard solder. This is a stick solder, and the reason I like stick solder is because you can stick feed it or you can nip off pieces You can even flatten those pieces and make your own pallions. It's a lot more versatile than pre-chipped pallions. So let's get some solder on this. You can just nip off a piece and put it on your block and just flatten it out. This makes it a little bit easier to handle, in my opinion. Now you're probably wondering, well, how much solder do I use? And that's a great question. There's a certain amount of waste that you have when you have to grind solder away. So really getting the right amount of solder is important. You got to consider, if you have a nice tight joint, it's a very small area that you have to take up. And if we were to take one of these small pieces of solder and stretch it out real thin, chances are one of these, or maybe one and some extra, would fill that gap plenty, and also come out and fill the little bit of extra space that we created on the inside here when we filed it. Since I think it's going to take maybe one piece and a little extra to get it soldered how I want, I'm going to use one piece. Now you see I'm handling the solder with my fingers. You're probably like, didn't you tell us to keep it clean? What are you doing? Well, you remember me saying that the flux is a self-pickling flux. And what that means is it's going to clean the gunk and the oxidization off of the solder. Since we still got wet flux on the inside of that joint, I know that as soon as it touches that self-pickling flux, that the oil from my hands is no longer an issue. We're going to get a lazy flame going. We're going to dry that flux. And the reason we're doing it gently and we're not just blasting it is because when that flux dries, it wants to bubble and sizzle up. And if it bubbles and sizzles up, there's the potential that it's going to throw your solder, your pieces of solder, it's going to throw them away. Another reason we do it nice and gently is so we don't start annealing the piece and deforming it and spreading apart our gap. So you see it's turned white. That means it's dried up, it's cured on there. Now comes the fun part. So you're going to get an appropriate flame for what you're working on. A nice focused flame is always good, because you know that there's enough heat in that flame to do the job. You can always pull away if you're like getting too hot. You can pull away, but watch that metal. So you can see that I'm heating up the tweezers. Why would I be doing that? Well, the tweezers are going to sap heat from the piece. They're going to sap heat from our bezel. And we don't want that to happen, because we want nice, even heat distribution to make sure that this works right. So we're going to heat the tweezers up. I like to get them like red hot. So now I'm going to start going around in a circle around my bezel. I'm going to hit both sides of it. You can see my pieces wiggling around. I could have pinched them in the tweezers, but I don't like doing that because as the metal gets soft, sometimes it deforms it. I'm not a fan of that. Alright, so now I'm going to start slowing my movement down a little bit. And I'll get a little closer. And I'm going to watch that metal because it's going to start changing colors. It's going to start getting red. And your whole entire piece of silver needs to be at temp for the solder to flow. So now we're starting to get up to temp here. I'm increasing my movement a little bit. Now that we're getting to temp, piece is getting hot, so I'm going to come underneath. Solder melts. You can see that solder flash. See it flash? See it flash? Now we're going to go to the front and we're going to try and pull some of that solder through because solder likes to follow the heat. So since solder likes to follow heat, we're going to put the heat where we want the solder to go. And you'll see that solder flash still. Even though your flame's on the opposite side of it, you'll see it flash. Just be conscientious. There it goes. There it goes. So you can see our two little spots are flattened out now. Those little pieces of solder are gone and they're melted into our joint. And you can see that we were in fact able to pull some silver through to the other side. And you can see that it's more solder than we needed. Like the whole joint got filled up. It was more solder than we needed. So we got a little bit to take away. But I think the main takeaway is that you tend to need less solder than you think you do. And the focal points of your heat need to be kept in mind. And it's going to get a little more important as you start adding more pieces. And then you check it on your stone. We still got a beautiful fit on our stone. And to clarify, when you're sizing up your stone and making sure that your bezel still fits, go through what is going to be the top of the bezel, because you can't just slip it over once the back plate's on. So make sure you go in through the front to test your stone. And if you have a soft material like turquoise or something like that, then make sure the inside is nice and clean and free of burrs or like extra solder or whatever before you shove it in there, because you could damage your stone. So now we got to clean the top and the bottom and flush them up and get those edges trued up. So this is a diamond file. I'm going to start taking off material with it. And that'll make a clean, flat surface. Because when you punch and form out your own metal, it's not always going to be true. As a matter of fact, I don't think it's ever going to be true. Like after it comes out of the rolling mill and you hit it with the punch and so on and so forth when you're making bezels. Um, the only way to get real, true, straight, uh, decorated bezels is to get a wheel for your rolling mill that lays designs into the silver. Other than that, you're going to want to get acquainted with a file or a few. This file will help to deburr the edges. So I'm going to take this all the way around the inside and make sure I hit each edge. And the same rules apply here as always. Once you're done with it, you want to make sure you don't touch it with your hands. I'm a fan of a good soft file for cleaning off backplate before soldering it. Good surface prep is always important. Always, always, always. Another thing that you can do is use something to clean it that won't leave a residue behind, such as alcohol or fingernail polish remover. Also, check your gap. Make sure that you got a good clean joint all the way around. Nice tight connection where your solder can flow. Okay, so this is pretty important. The type of block that you use is going to affect the transference of heat that your piece has, and also its retention of heat. If you have it sitting on a solid block, it takes a long time to heat the piece up because you have to heat the block up too. Now, with this waffle block, it has these little diamonds that raise the piece up and create flow underneath the back plate. This is very important because in this case, and in most cases, I would say, your back plate is thicker than your bezel wire. And that's important because your flame is coming from this way and is hitting your bezel wire first before it hits your back plate. So the way that you hold your flame, the focal points that you have are going to be important. This the shape of this piece actually works out perfectly for us because we have some locations from the top where we can hit the back plate to heat it up, here, here, and here. And on the waffle block, we can also blow our heat underneath it. So this is a good setup. Okay, so we flux it. What I did was took that flux brush and kind of worked a bead of flux all the way around. And now I can kind of move it back and forth. to spread some of that flux across the back plate. Now it's time to apply some solder. If you're having trouble picking them up with your tweezers, you can use your wet flux brush. Now I'm putting my flux on the inside. And then I can use the heat to draw it outward. Remember, you want a lazy flame to heat up your flux, to dry it on. So you can see that flux turned white. Focus our flame a little bit more. And I'm going to go around it. I'm going to try to heat up that back plate first. So if I can heat up that back plate first and then heat up the bezel, then I know I'll have even heat distribution. I'm going to start pointing my flame inward a little bit more. I'm going to try and shoot that flame underneath to get the bottom of that back plate. I'm going to start slowing my movements a little bit. Heat that back plate up again. Okay, now we're getting up to temp. Slow my movements a little bit and put some heat inside, outside, inside, outside, inside, outside, inside, and outside. Keep doing that until your solder melts. And then start drawing your solder out. You'll see it flash. You'll see it flash, and then pull your flame away. Yeah. So you can see where the solder was. You can see how we used the heat to pull it out. You can also notice that I didn't point my flame directly at the joint on the bezel while the piece was at temp. And the reason you really want to pay attention to when you solder that flash point is because if you let it go past the flash point of this solder, which is the medium that we put on, it's going to flash your heavy solder, and then your solder is going to start coming out of your seam that you did before. You don't want that. And then you see we didn't have to reapply any stop flow, and all of our designs are still intact. So for the sake of time, I didn't really film a lot of the refinement process on this piece, but here we're going to take the back plate off. We're going to take the bezel down to an appropriate height, and we're going to make some little notches and stuff like that to make it a little more decorative. And then we got to make a little notch for our jump ring to rest in when we solder it. So that's what I mean by refinement, is we're just making some small adjustments to the metal, filing it here, sawing it there, until uh, we reach the stage where we can actually get it polished and everything. So this is like rough refinement. So now I'm getting my jump ring prepped, getting it cleaned up, and I did some refinement on this edge and put myself a little groove right in the top here so that that jump ring sits in there nice and neat. So obviously doing it on the block like this is going to be more difficult. So let me show you another way. So now you can see what I've done is put my jump ring in a pair of tweezers, and what that's going to do is that's going to keep my jump ring from melting. And now we can see a little bit more what's going on. The block's going to suck some heat from the bezel to keep the bezel from melting. And then all we got to worry about is focusing on this back plate and making sure that we don't get it too hot. So we're going to go back through our steps, add flux, add solder, and you can see this also keeps it from sucking into from your flux, your liquid flux, from seeping into the block. Now we can do some damage here. Let's get that flux dealt with. All right. So let me explain what happened. The solder jumped onto the jump ring first. They were still connected, but the solder didn't flow to the back plate until the back plate was hot enough to accept the solder. So it's something you got to pay attention to. When your solder melts, it's going to go where it's hottest. Since the jump ring is thinnest, it heats up like quick. So that's why the solder jumped over to the jump ring, and then I focused my heat on the back plate to draw it back over and seal those two together. So now you can throw this into your pickle solution, but let me warn you now. If you're going to go the route that I went and use Argentium silver, after you heat it up, you want to just set it on your block and walk away and let it cool down. Don't try to quench it. Once it's cool, and you can handle it, now you can throw this into your pickle solution. For my pickle, I use just regular old vinegar that you can get from the grocery store and salt. And that creates an acid solution that will eat away the flux. It will eat away all the oxidization, and what you should be left with is a nice clean piece of silver. A note about using the vinegar and salt pickle is you will get some oxidization going on, so, and some fumes and stuff. So make sure you have something that you can like put it in. And also it works good to give it a hot bath. So there's hot water in here right now. And this speeds up the process of the pickling. So that should actually be done. But also note that when you use the stop flow, the rouge stop flow, that this vinegar pickle does not seem to take it off very well. And when you take it out of the pickle, you need to rinse that acid off somehow. So this is distilled water to keep the mineral content down so you don't get any hard minerals that dry on your piece. You don't want to contend with that. And then it has baking soda in it, and the baking soda bases out the water and neutralizes the acid. Okay, so I figured we'd do one more solder step just to show you guys. And what I ended up doing was making a bale for this. Now this here is extra easy solder. It comes, this stuff comes in a tube, although I'm certain you can get extra easy solder in other forms. And with this stuff, you only need just a little bit. I mean, essentially, it's like fine silver dust and mineral oil. And then you can see I got some of our rouge stop flow on the jump ring, just as an extra precaution. I don't think it's going to run because it's not connected. When I fabricated this up, I made indents so that it wouldn't touch. But you know, as they say, shit happens, and you just like to be prepared. And this stuff is extra easy, so I'm not really worried about anything else melting. We're just gonna dip in and dip out. Here we go. Now you can check and see. Looks like we probably want to heat it up a little bit more. You can see that solder didn't quite run all the way. This is just need to be careful. So you can always go back in. Flame down. And I'm gonna fire that bale. Get that bale hot. That's really all I want. There it goes. Didn't even touch the pendant with the heat that time. It just hit the bale. Alright, so there we have it. You just need to push in your bezel, and then it's a done deal. So let's go over our points again. We gotta have tight connections, make sure our surfaces are prepped properly, make sure that we're watching our heat, controlling controlling our flame as much as possible, controlling the distance from from our piece, focusing on which parts need to have more heat, less heat, etc. And then always consider your silver thickness. We talked about flux and a couple different flux types. There's one more. We're not going to get into it right now. We'll get into it another time. But different solder types we went over, and then how to control the flow with your flame, basically, because we talked about how it wants to follow the flame. So, yeah. Anyways, if you enjoyed this video, please like and subscribe. I would really appreciate it. And if you have any questions, leave them in the comments and I will get back to you. I know that this can be kind of challenging at first, and I am more than willing to help however I can. As I grow this channel, I want to try and leave advertisements and stuff out of it as much as I can. So any of your interactions with my content goes a long way towards that goal. Thanks, guys. See you next time.